This is what we have said, the students within the classroom and the many schools. The cluster is a higher level is a school, and the variability between school is our interest. That is regarded as a random variation. Multi-level contains more than one error term. Please remember that when you write the regression equation, y equal to a plus b x. Usually we don't write this EI, the error. This is, unless you have the EI part, the predicted value will not be equal to the observed value. The error. Error follows normal distribution with the mean zero and variance, some amount of variance. Important assumption is that the error EI should follow normal distribution. So yesterday we spoke about that. How do I know that the repeated message data or whatever follows? Do you remember the heterogeneity which I said that each observation in dose level, there is a normal distribution. That can be tested using this error concept. Okay. We don't test that kind of thing. If this is normal, every assumption is met there. Here, but in random intercept models, which we have seen, random or random slope model, which we are going to see today, that you have doctor level, then let's say I set institution level, then each level will have doctor level error term, okay? And you have institution level, so therefore institution level error term and so on. It's a K, not I. So this is we need to remember. So, and the regression allows you to have, when I say there is an error here at this level, there is an equation for this level. There is a regression equation for this level. This is what we are going to see. Now the question is, because you have a structure of different levels, should I consider all this level in my analysis? So that is what we are going to evaluate today. And though there is a structure, should I have that structure in my analysis or not? If the analysis says yes, you should have, then you should have it. Okay. What is important here is that this is I'm just using this opportunity to introduce you to this random slope model. What is random slope model? If I'm dealing with the three doctors, asking them to have a different start-off values. Whereas in this regression, see here, there is only one intercept. If I allow doctors to have each one to have one regression equation, then A becomes AI, A1, A2, A3. You can assume they can have a parallel slope. So if that is a concept, then say for example, your regression equation or line would be, if it is a parallel, then Dr. 1 has a line like this, Dr. 2, Dr. 3, and so on. So they are starting at a different level, but they have a common slope. The slope is your tangent. Is that right? So the slope is same, assuming the rate of change is same, but they are starting at a different level. That is why it is called a random intercept model. So you have 12 doctors, and you'll have 12 intercept. The between variance of the 12 intercept is called intra-class correlation coefficient. The variability across the intercept is called intra-class correlation coefficient. Why? Because that is a cluster. Each doctor is a cluster. The variability between the cluster is called intra-class correlation coefficient. So in any analysis, multi-level analysis, that is some minimum that you should have. Now the question may be, you can ask the question, should I have this random intercept model or simple linear regression model? Okay. So the first thing is you need to evaluate that, whether I need it. If yes, then you need to know what is ICC, estimated ICC, and how does it change the covariate standard error, etc. That is the exercise which we are going to see. Do you have any questions? So we assume that each doctor has a different role to play, and therefore they are different. Okay, the measure which you derive from individuals of these doctors, like age and cholesterol, that relationship is common. That is the same slope. Rate of change between age and cholesterol is same for all doctors, but the starting point is different. This is called the random intercept model, and the variance between these intercepts is called ICC. So this is let us go back to our slides. Let me introduce this notations to you. Yij, the group is J. So group means I have 12 doctors, means I have doctor 1, doctor 2, doctor 3, doctor 12. So these are 12 groups I have. Between groups, variability is ICC. So I is a subject. Okay. Always remember, the lowest level, you don't think about intra-class correlation. One level above the lowest level, you need to think about groups. Okay. Say for example, individuals are measured at the bottom level, age and cholesterol level. They will never form a cluster. The one level above them is doctors. So you have to you have to be very careful about levels. The lowest level is not considered as level at all. It gives you observations. Now, so you know what is I? I is the individual cholesterol level. Y means his cholesterol level. I is I1, subject 1 cholesterol level. He belongs to doctor 1. So Y11 means he belongs to doctor 1, the first subject, his cholesterol level, and so on. So this is I and J. This is what I said, the advantage of doing multi-level modeling is you can correlate the doctor's information into the modeling. That is, so therefore explanatory variable at the group level. Z, so J is that there are 12 doctors, therefore, say for example, the age of the doctor. So say 51 means, 50_1 means, that means that the first doctor age is 50 years. Is that clear? And so on. So this is Yij, this is what I have said. So therefore, Z means the covariate of the clusters, doctor's education, experience, etc. That is Z. X is patient level characteristics. Y is the patient level dependent variable, cholesterol. Any questions? Doctor level. I is the lowest level. Ij Then if you bring in institution, it becomes K. Do you understand this? So the structure, you can bring in any level. This is what I said, the error term. This is simple linear regression. We call it as a naive model. Just as age increases, whether the cholesterol increases or not. Okay. That is what we do. If you wanted to have, is there any difference between male and female? That you run the regression separately for male and female. And you can adjust for gender as well. But that is not the aim. So we wanted to have different lines. That is what your question would be, is there any difference between these two things? Okay. So now this is the data of the male and female on cholesterol. And now it says there is no significant difference between the two. Okay, gender. Can I do this, some other analysis to address the question? Is cholesterol t-test. How much is the difference between these two levels? What? 0.02 units. Okay. Is that right? So that has to be your regression coefficient. The difference between the two means has to be the regression coefficient. You move from 0 to 1, what is the corresponding change in your regression coefficient? So you move from 0 to 1, there is 0.02 unit increase in your cholesterol. That is your regression coefficient. Difference between the two means. So then this is what is 0.02. Is it okay? What is a constant term? When x becomes 0, 5.95. We understand. So when you use the 0 and 1 codes, it is mimicking the t-test. When you have 0 and 1 codes, male and female, rural, urban, socioeconomic status, and so on, it's exactly same. The mean value of 0 coded variable is your constant term. That is the base at which it increases. This is the base, then the regression increases by. Okay. So this is the model now. It's called a fixed effect model. Why do I call it fixed effect model and random effect model? There are many names for multi-level modeling regressions. Random coefficient model, hierarchical model, because you deal with the different levels. I said multi-level model, hierarchical model, random coefficient model. Why do we call it as a random coefficient? This is not random, this is fixed. There's only one constant term. But if you allow this to vary for the doctors, then it becomes random. You understand?
What is the exact
Fixed is only one, because the random means we allow them to vary and measure the variability.
the level of this constant beta?
Constant as well as the slope also. Slope, random intercept and random slope. That is why it is called random coefficient model. The coefficients, constant term is a coefficient. The slope is a coefficient. So we allow them to vary, therefore it is called a random coefficient model. Is it okay? Yeah. No, same only. The jargon is different. Random coefficient is multi-level modeling, hierarchical modeling. These are all different names. Yes, sir. Same mixed effect models. Because you allow some coefficients to vary, some to be fixed like that. The slope doesn't change, so it is fixed. You allow only the random intercept to vary. That is called a mixed effect. Why it is called a mixed effect? You have some regression coefficients to vary, that is random. Something is fixed, therefore the fixed and very random put together is called a mixed effect model. You understand this? So do you understand this? Random coefficient, random sum, if I allow this to vary by doctors, but I don't allow the slope to not to vary, therefore it is fixed. Slope is fixed, but the constant is allowed to vary. So each one start with a different level, therefore random. And other one is fixed, slope is same. This is fixed, therefore it is called a mixed effect model. Yes. All the no. Yes, correct. All the naive models mean simple regression, fixed effect model. Is it okay? Is it a mixed effect model or random fixed effect model? This title is fixed effect model. So this is I don't change the slope. It is just the same. If I allow this to change, what kind of notation will I put? Okay. Let's see. See here, constant of this is a random slope model. The J is allowed, the random intercept, this constant term is allowed to vary. Therefore, it is called a random intercept model. I attach the J. What is J in our analysis? Doctor level. So what does it mean? I allow J number of doctors to have a different slope. Therefore, it is random intercept. Okay. And this is, what is this one? Slope for doctors. So this means I allow the doctors to have a different starting point and different slope. Can you imagine what kind of graph that I'll have? It's very simple. So I should allow, this is my, okay. Okay. Random intercept, shall we do first? The model is random intercept and slope. Therefore, if I take a doctor one, that he has a random intercept, okay. So therefore, this is doctor one, say for example, doctor one, random intercept. So random slope means there are two ways of putting the slope. One is parallel, then it is not random slope. Say for example, the next doctor has a, is it parallel? This is doctor two. Is it parallel? Then the third doctor started off with a high value, dealing with alcoholic patients or whatever. So therefore, the responses are going down, but he started off with a very high value and going down. This is called a random intercept because everybody starts with a different level and different slope. That is why it is called a random intercept and slope. Always remember the last question. Should I have this in my model? Should I complicate this analysis by having too many assumptions in my data? That's something which we need to address. Do you understand this random intercept and random slope? How do I write? So when somebody writes the model in a paper, if he writes this as beta j, that means he allowed the intercept to vary plus beta 1 j means what? This is 0 means constant term, please remember. Beta 1 means that is cholesterol level. cholesterol level variable, and that has J attached to it. So therefore, the slope is likely to vary between the doctors. So, and so on and so forth. Somebody need to tell me what is this one? Supposing this is fat or whatever. This is second variable, covariate. Except the zero, I allow everything else to have a different slope, etc. Any questions? So this is understand the notation. So when I have a Z, I can bring in Z, characteristics of the doctors. Okay. Z means characteristics of the doctors. Okay. So therefore, you see here, Zj means, so allow the doctors to have different values for, allow the doctors to vary in their responses, covariates. Okay, this is the error term. Error term at what levels? The lowest level I, and J means doctor level. So you have the lower level variable error term and doctor level error term. Therefore, it is called a random coefficient model or whatever. So this is J, do not depend on J. This is what I've been telling you. Every time you just say, because you have the software and techniques to do this analysis, don't complicate the model. Always ask the question, should I have it? So just make sure that whether that level is necessary or not. Just leave that level and make the model very simple. Okay. Fixed or random parameters. Tell me, what is this model? Mixed effect, random intercept and random slope. Okay. And it is not mixed because there's no fixed effect here at all. Okay, it's a purely random effect model. When you say mixed effect means that you have a fixed term. There's no J attached to that level. Usually, the bare minimum is that the intercept is allowed to change. The slope, this is called the slope. B1, beta 1 is called the slope attached to the covariates. You don't have to allow this to change. Then if there is no J here, it is fixed. But this is random. So therefore you call it as mixed effect model. Generally, it is called a random coefficient model. Okay. Which one? That is, you have, because J is there, J will have, doctor level will have a term, and the individual level will have a term. Yes, error EIJ. And the book uses called R. You see, I wrote as E, error. What is this model? Yeah, random intercept and fixed slope, okay, parallel to each other. So purely random intercept. Is it a cluster? Random intercept is a cluster. If you study the variability between doctors, that is called ICC. Because doctor is a cluster, do you remember in the introduction part, I said between cluster tells you about what is intra-class correlation. And within cluster, between cluster, the A, do you remember variance A, sigma square, A plus sigma square, W is within cluster, and so on and so forth. Between cluster variability is very high, then the ICC will become larger or smaller. Something we'll have to see. So therefore, by this theory, This is the variability which we are interested in. This is the beta zero, the slopes. So we are talking about intra-class correlation coefficient now. It's the average intercept and the regression coefficient of X is the regression coefficient. Let's see this one. This is, there are 12 medical doctors, therefore you have 12 lines attached to it, random intercept model. Do you understand this? What is that? Medical doctor is coded as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is not a continuous variable. Gender was coded as a male or female. It's not a continuous variable. So now how do we analyze such a data? So if it is a gender, you can look at different analysis and see what is the regression coefficient for males and equation, female equation, and compare it. When you have 12 doctors or more doctors, how do I do it? If there are more doctors, then we are suggesting that analysis suggested that you need to have dummy variables introduced to the doctors. What did you do for the male and female? You drew one line for male and one line for female and looked at the data, regression coefficients, etc. But when I have 12 doctors, what will I do? So for example, 30 clusters, 30 doctors or whatever, 30 communities, etc. It's very difficult to do that kind of analysis and studying the variability. So therefore, you need to introduce a dummy variable, put it in the model. What is a dummy variable? This is, if you have 12 doctors, you'll generate 11 dummy variables. And there's a dummy variable for doctor 1, doctor 2, doctor 3, and so on, plus your term. And this is basically, there should be 11 waste of power and efficiency. So instead of having one variable doctor, that you have 11 such variables in the analysis, which is not. So therefore, we understand this is the organization of the doctor data, and it's a medical doctor 1, and his patient's data, age, and he belongs to institution 1. Okay. When we talk about higher level, we'll talk about institution. We'll deal with the doctors now. This is different. Those days we had, I said we started off analyzing data in 2000, around 2000. That time we bought a new software called MLBin. It's developed by UK universities, meant only to analyze such data. Very useful software. It tells you this is, now tell me what is the slope here? The slope is 2.7 and the standard error is this. And this is a constant term is 2.7 and the standard error is this. The slope is 0.05 and the standard error is this. If I have to do this analysis using R today, that is what we are going to do. It's a free, this is the analysis. This is your linear regression formula in R code. linear model formula is this. TC total cholesterol is a function of age and data is a cholesterol. It's a very simple command to remember. I'm doing naive analysis, simple regression analysis using R code. And so you don't see anything else except this equation. So it says that if there is a 1 year change in your age variable, 0.05 units increase in your cholesterol level. Is that right? Is it significant? This is standard error. This divided by this is called Wald T test. Wald test. So this is 11.92, which is greater than 1.96 or 2, highly significant. So there is a significant correlation between age and cholesterol level. Okay. Now, what is our next job? This is the likelihood statistics. Okay, likelihood. Please remember, we are going to use likelihood very much as you evolve as a good researcher. Tomorrow, and day after tomorrow, next year, and so on, you will be dealing with likelihood statistics. Okay. And so this is very crystal clear here. What is random here? Random. What is a random here? Which is it a constant term or is it a slope? See here, the constant term has a J. What is J? J means doctors. So it's a random intercept model. You are allowing the constant term vary across doctors. Therefore, it is a random intercept. By looking at this equation, you should be able to say. But today we are going to use R code. Therefore, we need to see how does it look like in R code. Is that right? This is your R output, which you are going to see in a while. Now, likelihood is 404. Okay. And what is the regression coefficient point? This is also 0.05. Standard error is this. But how do I know this is a random effect model? See here the formula. Whenever you deal with the random intercept model, it gives you delta sign and 1. 1 means it is constant term, beta 0, okay? And it says given MD. Doctors are allowed to vary across to have a different intercept. That is what the meaning is. We understand? Therefore, it is called a random intercept model. Let me repeat it again. Please, this is what you need to remember, because it doesn't give you J or I or whatever. Whenever you see delta 1, it's called a random intercept model. Is that clear? Okay. And given MD. If I have model it for an institution, what does it give? Given institution. If I allow the institution to vary different levels, delta 1 given institution. We understand. So therefore, it means I allowed the institution to vary with the starting point. So this is what you need to look at. Given MD, doctors are allowed to vary, therefore it is a random intercept model. I'll show you in a while how does the random slope model look like, okay? Now the question is, should I have random intercept model at all as compared to naive model? Do you understand my question? So how do I do it? What is the likelihood value? 404. 404. What was the likelihood value here? Minus 545. That is 404. There's a big difference, isn't it? How much is the difference? 100 plus. What is the change? What did you add in the next model? The later model, random intercept model. So on J, you allow doctor level to change. Therefore, extra 1 degree of freedom. Added 1 degree of freedom more. So the difference is 1 degrees of freedom, but the change in likelihood value is 100 plus. I told you the day one, as the likelihood values decreases, the model is getting better and better. Likelihood, remember, observed minus expected. Expected is what? From the model. Model predicts. The predicted value is as close as 0, then it's a perfect model. Do you understand? So if I put the doctor level into the model, it is becoming better. Therefore, the likelihood value becomes lower and lower. So without the doctor level 545, with the doctor level, it is how much? 404. Do you understand this? So getting better. And now, so therefore it says that we should have doctor level as a random intercept model. Is that clear? Okay. Now, is there any change in the regression coefficient after adding the doctor level? Standard error? Please remember, very often you change in the variability statistics. Therefore, you have to look at the standard error, not the point estimate, regression coefficient, but the standard error. The regression coefficient is 0.05. In the earlier model, 0.05. This model is also 0.08. Seldom find a big value change in the coefficient, but the variability statistics will change. What was a standard error earlier? 0.004. It is 0.003. You might be wondering, is it a big difference, 0.004 and 0.001? It looks like there's a big difference in terms of p-values, etc. Please remember, write the equation. -2 log likelihood follows chi-square distribution. Let me write it for you. So what ideally you have to do is, this is -2 log likelihood follows normal distribution, sorry, chi-square distribution. Ideally, what you need to do is take a difference between the two likelihood values, 404 and 550, 45 or something. Take the difference, multiply by 2, then it becomes 200 something. Okay, that follows chi-square distribution. Or you take the difference, what do you get from the R code? Take the difference, multiply by 2. That is a kind of chi-square value difference you get. Okay, for 2 degrees of freedom for chi-square test. Do you remember what is the chi-square value for 1 degrees of freedom? Please remember this. 3.8, 3.84, nothing but 1.96 square. Remember, it is 4. For 2 by 2 table, it is 4. And if it is this is 2 to 1 degrees of freedom. 2 degrees of freedom, you need to have 5.4 or something. So you can have, remember, 6 as the minimum value for 2 degrees of freedom. So we added one more J into the model. I increased one more my degrees of freedom to one more unit. Okay. So 1 unit of difference in the degrees of freedom, the corresponding chi-square value has to be minimum 4. But I got 200 plus something. It's highly significant. It suggests that the model has to be minimum random intercept. You have to add doctor level into the analysis. Okay, that is the message which we have. Any questions? Please don't ever look at the magnitude of the regression coefficient, but the standard error. Okay, is that okay? And this is then the slide. In any R program, if you see delta 1 given something, it is a random intercept model. Please remember this. Then you must be wondering, how do I write the random slope model? Let's see. Okay, this is what we said. The difference is 2 times of this, 2 times of this, and take the difference 282. Minimum what I needed is 4, but I got 282. Is a phenomenal difference. Okay, and now the next job is, okay, what is the ICC in the data? We said subject specific model, not population average model. Yesterday, we all remember we used exchangeable correlation structure. This is structure, it doesn't give you any value. Today, the random intercept model should give you actual value of ICC. Okay, so how do I calculate ICC? See here, the standard deviation, this is called the variance. Okay. What does it say? The variance of the intercept is 0.60. And the residual variance is this. So how much is the total variance? Almost 1.2 something. I'm adding this too. Do you agree with me? Total variance is 1.2 something. How much is at the intercept level? 0.60. So 0.60 divided by 1.2 is your ICC. The variability across doctors is 0.60. Total variability in the data is 1.2. 0.60 divided by 1.2 is 50%. So you got the exact correlation which is going on, which is very high. 0.52 is very high. Okay. So if you have data and you can estimate it and decide whether we can report it, please report it first of all. And use this to work backwards and see whether we have studied enough number. Yesterday you asked the question. So this is not available very much. So therefore, if you see here, if you put this command there and the ICC is 0.52, which is very high. Do you understand? So the random intercept model raises a question. 1, do I need this model? Next, how much is the intra-cross correlation coefficient going on in the model? So 2 things have to be addressed in random intercept model. Is it okay? So next one is, I think that is all I have. Yes. 0 to 1. So just like a correlation coefficient. Say for example, as I said, the responses of subjects within a cluster. You take 3 children and measure their malnutrition level. If they are expected to be highly correlated because the numbers are 3. But randomly pick up children from the village and try to estimate the correlation, it will be smaller. As the number of subjects within the cluster becomes smaller and smaller, ICC becomes larger and larger. Please remember this. Yes. Yeah, you can look at this, but unfortunately, we don't have any guidelines on what is the threshold for ICC that to go by. Is it 0.2 or 0.3? We don't know. So only through log likelihood, you should do that estimation and see whether the model is necessary or not. Okay. One school of thought is, because we have the technique, whether it is necessary or not, don't evaluate it, just do the modeling with the random intercept model. Okay. But always the saying goes, have a simple, elegant model without complicating it. Sometimes you are happy with the simple regression model. That is enough. Because if you have the software accessibility, don't complicate it with the random intercept model if it is not necessary. Is that okay? So any questions we'll discuss